Hello, I am Kalidas. Welcome to Quality and Welding Metallurgy. Today we are discussing on welding distortion and control. What is distortion? Undesirable change in original shape is called distortion. Distortion occurs due to heat input and mechanical force. Experiment number 1. Uniform heating of the steel bar throughout of its entire volume. Considerable expansion takes place in all directions. Now, if cooling of the bar is allowed evenly, retain its original shape and size without distortion. So we can say that uniform heating and cooling of the component that can expand and contract does not cause any appreciable distortion. Example, experiment 2. Repeated experiment number 1, but heat the steel bar in clamp condition and see the change in shape and size after cooling. So we can conclude that restraint hinder free expansion and contraction and cause material to deform, resulting in distortion. Heat input, gasketing, heating, welding. Distortion in case of spot heating. Heated area expand. Expansion restrained by surrounding solid area. Compressive stress are developed. Further, compressive stress lead to plastic deformation. Material bulges at the spot towards heat source site. Cooling. Spot area tend to contract. Contraction restrained by surrounding hot area. Material goes back to original position with plastic deformation, resulting distortion. Longitudinal distortion. Distortion in butt weld. It is contracting along the length of the weld. It is maximum along weld bed and decrease at points away from the bed. In CS of cell, it leads to reduction in diameter of the weld. Longitudinal shrinkage. Longitudinal shrinkage, butt weld in CS and LS, cast carbon steel and low alloy steel. So please follow the factor and this formula. Example, calculate longitudinal shrinkage from 6 mm CS plate, carbon steel plate welded by SMAW using 200 ampere current. Solution, longitudinal shrinkage 3 into 2, 200 into length into 1 lakh into 6, length divided by 1000 mm. Longitudinal shrinkage Fillet weld. Distortion butt weld. Transverse distortion. It is the shrinkage perpendicular to the weld. It leads to development of high residual stress and also cracking in case of highly restrained joint. It is not uniform along the length of the plate. It is laser at the end of the plate where bed is started. Example of a transverse distortion. Transverse shrinkage, single pass butt joint. Transverse shrinkage 0.2 across section divided by thickness plus 0.05 fine root opening. During multi-part welding, transverse shrinkage TS plus V, a coefficient log W, total weight of weld minus log total of weight G. Procedure: root gap, joint design. Root gap TS, transverse shrinkage, increase with increase in root gap. Joint design, single V produce more transverse shrinkage than double V. Electrode dia, transverse shrinkage decrease with increase the electrode dia. Degree of constant, transverse shrinkage decrease with degree of constant. Pinning, transverse shrinkage decrease by pinning. Gouging and repair, TS increase by this operation. For T joint with two continuous fillet weld, go to this formula. Transverse shrinkage in fillet weld. For intermediate fillet weld, a correcting factor of proportional length of the fillet weld to total length of the joint should be used. For fillet weld in lap joint between plate of equal thickness to weld. Angular distortion. After welding at the original shape position. Distortion of butt weld, it is the bending transverse to the weld due to non-uniform heating and cooling along the thickness of the plate. This is the main source of mismatch and dimensional increase in the large welded structure. See both side welding technique in place, single slide welding. Angular distortion of fillet weld. Example of angular distortion and fillet weld. Find the angular distortion in a double fillet weld of joint T joint between a flange 1000 mm wide and vertical member when The thickness both the member in 6 mm and the weld leg length is equal to 8 mm. Multiple restraint fillet weld. In multiple restraint fillet weld, the span length is 1 meter and the angular change is 9 degree at distance of 400 mm for the span and span in. Find the distortion solution like this. Distortion in T-joint. Longitudinal distortion. Pulling effect toward natural axis. Longitudinal distortion, pulling effect of weld above natural axis. Thank you. Please see my next episode for distortion. Thank you.